So today's lab, okay, what we're trying to do is confirm what factors can affect the period of a pendulum. So in other words, we're investigating this formula. T equals 2 pi times the square root of L over G. Okay? Now that formula contains the two things that actually affect the period of a pendulum, right? But we always, when I asked you guys what things would affect how long it would take a pendulum to swing back and forth, you gave me some other things. Okay? You told me that, the weight on the end of the pendulum and things like that could affect its period. And I told you no, and you looked at me like I was crazy. And that's fine. Now I'll prove to you I'm only crazy in certain respects, not in this respect. Okay? So, we're going to prove what things actually affect the period of a pendulum with an experiment today. Now, the experiment's going to be a little different than some of the other ones we've run because we're actually going to be testing 3 different manipulated variables. Now, a true experiment can only have 1 manipulated variable. So this experiment's actually going to be broken up into 3 parts. Okay? But in order to not multiply the amount of work by 3, okay, we're going to simplify some of the design parts of this lab report so that we don't have to have 3 different sections kind of outlined. All right, so the problem we're investigating, obviously, what factors influence the period of a pendulum and what relationship do they have. Okay, we're going to break the design up into different parts because we're actually doing 3 separate small experiments. Okay, each part will have the same variables, but in each part they will change from controlled to manipulated. All right, so when I'm testing length will be the manipulated variable, and then all the other things will be controlled. Okay, that'll be like mass and drop angle and all of that kind of stuff. Those will all be controlled. And then when I'm testing drop angle, length and weight, or mass, will be controlled, and so on. So we'll just keep kind of flipping back and forth. So what we're going to do for the design, rather than say manipulated as this, responding as this, controlled as this, we're going to identify the variables that will change. And then we'll simply list that they are controlled in some situations and they are manipulated in others. Right? So we're not going to actually say manipulated part 1 this, manipulated part 2 this. We're not going to do that. The one thing that is the same for all of them is the responding variable. What are we measuring about all of the pendulums? The period. Yeah. Okay, so we got to keep that one in mind. Okay, for our hypothesis. Okay, if, and then statement, same as always. Okay, the if part needs to tell me what you think will affect the period of a pendulum. Okay, so if this factor or these factors affect the period of a pendulum, and talk about the experiment where we're going to test them, okay, then what will you see? And what I mean by what you will see, don't say the same thing you said in the if part. Okay, tell me a little more about it. Like, as a pendulum gets longer, the period will do this. Or as the weight on the pendulum gets heavier, the period will do this. Okay, or whatever it is you think. Okay, so actually make a prediction in the then part of your hypothesis. Okay, so like we said, there's going to be 3 different sections to this lab. Part A is going to be testing the effect of mass on period. Right, so we'll have the single mass on there, so we're going to start with these masses here. We're going to put 50 grams on the end, 100 grams on the end, 150 grams, then 200 grams, okay, and just see. Now we have to make sure that we're dropping it from the same angle each time, so when we build our pendulum, we're going to take these retort stands. Notice how I pronounced that. Please write it as such in your lab report. It's a retort stand. Please do not write that it's a retard stand, okay? That's not very nice. And I get that all the time. Okay? All right, so we're going to have our pendulum, have it as close to the edge of a desk as possible. We're going to use the ring clamp to get it out over the edge, and you'll tie on a piece of string, okay, onto here. I'll have these protractors. Grab. Okay, so these plastic protractors here, okay, you'll just tape them on to the ring clamp. Okay, once you've got the pendulum on there, just tape these on, and then you'll be able to measure the angle from which you drop the pendulum each time. Okay, so make sure that's set. Okay, so for part A, okay, we're just going to do this, and we're going to make sure that our angle is 15 degrees from vertical. All right, so vertical is 90 on that protractor, so you're going to go up to 75 degrees and then let it swing. All right, and we need to make sure that our length is consistent on there. Okay, and I think you guys can choose that. It didn't actually say how long it needed to be, as long as it's the same length. Okay, for all of the trials. I would say probably a reasonable length there would be like 30 centimeters or 40 centimeters. Don't make it any longer than that. Okay, and make sure you note that in your chart. Okay, so you'll have that first one where you're testing the different masses. Okay, you'll record all of that data. Then you're going to do a second one where you're recording the amplitude. You're going to drop it from 5 degrees, 10 degrees, 15 degrees, and 20 degrees. Okay, and see whether that affects the pendulum, the pendulum's period. Okay, keep it the same length as the first part of the experiment, whatever one you use, so you don't have to change it. Okay, and then just keep the mass the same, right? And I think it says on here that you will use the 200 gram mass, okay, throughout that part of the experiment. Okay. Then lastly, you're going to test length. Okay, now this one, we should know already what's going to happen with that because it's part of the formula. Okay, so you're going to be starting out with, and you'll start actually down here. Okay, your longest one I think is going to be a meter. Say on there. It doesn't, but okay. What we're going to do is we'll just write in the lengths here. Okay, so we'll start out with a meter long. Okay, then we'll go to 50, so 0.5 meters. Okay, we'll go to 0.25. And 0.125 meters. Okay. The reason we're going to start with the longest length is so that we don't have to keep tying on new string. Okay. The length of string you take at the beginning of this lab is the only length of string you need for this lab. Okay. Is everybody clear on that? Get about 1.2 meters worth of string. Okay. That way you can tie a knot and you've got enough string to have a 1 meter long pendulum. For all the other ones, it's only going to be 40 centimeters, so just tie the knot so it's 40 centimeters long. Okay, and then when you're doing the length one, we'll start with a meter, shorten it to half a meter, shorten it to 25, shorten it to 12 and a half, and you're good to go. Okay, you shouldn't have to keep cutting lengths of string. Okay, one length of string should get this job done. Now, where do you measure the length of a pendulum to? Not just at the end of the string, the end of the little mass that you've got on there. Okay, so the length of the pendulum has to go, it's actually truly to the center of the mass, so just make sure that you're getting that included. Okay, when you're actually doing your measurement, mark it on the string and tie it the right length. Okay? In the end, for the first two sections, you can tie it wherever you want, okay, and just measure how long it is. You're not going to change that for the first two anyway. All right, so you'll have those three things, okay, and then you'll be going on to the analysis. So you're going to plot three graphs, okay? The three graphs are going to be, okay, period on the y-axis, because that's a responding variable, and whatever the manipulated was. So if it was drop angle, okay, you'll have that there. You'll have your graph, okay? You'll have mass and period, and then you'll have length and period, okay? You'll have three graphs. Okay, and they should show you pretty well, okay, what the relationship is for all of these. Okay. Then conclusion and sources of error. Okay, now when we're measuring the period, okay, look at what we're timing. All right, we're not timing one swing. We're actually counting the number of cycles in 20 seconds. Okay, so it's a little bit different. So someone's going to be timing, and you're going to have to count the number of cycles. Remember, one cycle is if I pull it out to the left, I let it go, and it comes back. When it's back here on the left, that's one. Okay, everybody clear on that? Now, if you're timing it, are you going to have to estimate? Because when 20 seconds happens, it's probably not going to be back here at the end or beginning of a cycle. So, estimate as best you can to the nearest quarter of a cycle. Okay, so quarters of a cycle would be maximum amplitude, equilibrium, okay, maximum amplitude, equilibrium, maximum amplitude. Right, so just give it to the nearest quarter of a cycle. Okay, from there you can calculate the period and the frequency, right? So frequency is the number of cycles per second, and this is the number of seconds per cycle, right? You should be able to get that from your data here on the number of cycles in 20 seconds. All right, any questions on what we're doing? Okay, so the acquisition of data for this lab should take you like 15, 20 minutes tops, and then you got the rest of the time to work on the lab report. Okay, it isn't due until the Wednesday after the holiday. Okay, so it's not due the day you get back. You don't have to do it over Christmas, right? Have it done for the Wednesday. Okay, everything you need is up front here, guys.